So hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk about. So finally we are going to start our pattern wise sheet, and we are going to learn about all those patterns which we have discussed in our very first video, and now we are going to do or solve problems on each patterns now. So here is our sheet named Rising Brain, that is pattern wise DSA sheet, and I hope you are aware of it. The link you can find in the description. And here is our 4 different patterns of array: true pointers, sliding window, prefix sum and cadence. And let's start with the very first pattern, which is 2 pointer, and the first question from this pattern, which is 2 sum 2 problem. So here is the problem statement. You can read. You will be given an array index which is already sorted in non-descending, means ascending order. You have to find 2 such number that adds up to target, and you have to return the indices of those 2 numbers which sums up to target. Remember, there is exactly one such solution exists, so you may not use the same element twice. Now let's read the constraint here. The constraint is 3 into 10 power 4. Here we cannot go for n square time complexity, and number ranges from -1000 to +1000. It is also okay. So here is the problem statement. Now let's come to our screen. The problem says you will be given an integer array, and your task is to find such 2 numbers which sums up to target. Okay. So 4 patterns we know: 2 pointers, sliding window, prefix sum and cadence. Okay, 2 pointers we know whenever we need 2 points starting from first index and last index, this can be used here. Okay. Second one is sliding window. Sliding window we always use when we want continuous subarray or continuous window, correct? Here in this case we don't need such subarray or window. Okay, so we can ignore this one, correct? We can ignore this one. Now third pattern is prefix sum. Prefix sum also we require when we want the continuous summation of subarray. Summation of subarray. Like for this 2, 7, 11, we want the summation to be 9 plus 11, 20 to be stored. And if we have to store or play with this 20 number, then we can think of prefix sum. Okay, so prefix sum also fails here. Now next pattern is cadence algorithm. When we use cadence algorithm, we use cadence algorithm when negative number exists in our nums array. And from here you can say ki yes, in the screen you can see the constraint nums array belongs from -1000 to +1000. You can little bit think of this cadence algorithm. Okay, but remember, cadence has not only one definition that it contains negative number. No, it asks for the continuation summation also. But again in this problem it is not asking for the continue summation. No. So hence cadence also fails in this case. So we can go with the 2 pointer approach, and you can find it out when you know all the pattern, how to apply and when to apply condition. Then you can identify which pattern to apply in a particular question. So in this question you have to apply 2 pointers. Okay, but forget about this if you don't know about the pattern. So what will be the brute force approach, your brute force approach? Okay, so if you do not know about 2 pointer, you will start your pointer from I is equal to 0, and as said, you cannot repeat the same numbers twice. So your j pointer should start from the next index. I am sure you know this. Now it means you have to run a for loop I is equal to 0 to I less than n minus 1 I plus plus. Why n minus 1? Because we are starting our j from I plus 1. So that is why it is very important to stop our I pointer till last second index. Otherwise, if we will stop our I index at the end, then j might go out of index, and that we don't want. Okay, and now second loop we will start for j, which is from I plus 1, and it will go till j less than n and j plus plus. Okay, now we have 2 for loops for I also and j also. Now what we would like to find? We will find a summation here. So we will write sum is equal to, what will be the sum? Sum will be nothing but nums of I plus nums of j. So if our nums of I plus nums of j is equal to target, if nums of I plus nums of j is equal to target, in this case what is the question expecting? Question is expecting us to return the indexes. So here we can simply return I and j, correct? Okay, if it does not exist, in this case we can return minus minus saying it has not been found, but in the question it mentioned that it is there, so we do not need to return anything. Okay, but now let's see the time complexity here. How to calculate time complexity? This for loop is running for how many times? If you can see closely, the first for loop is running for n minus 1 times. N minus 1. Okay, let's write it. So O of n minus 1 times. Now the second for loop is running This is also running for n minus 1. Why? Because it is starting from first index and going till last. So again this is also O of n minus 1. Why I have multiplied? Because nested means for every value of I, each value of I, j is running for n minus 1 time. You can see when I was 0, j run for 1, 2, 3. When I was 1, j run 2, 3, etc. Okay, so if you multiply this, you will find n squares minus something. But in time complexity, we always take the larger one, and that larger is n square. And as you saw, the constraint is already 3 into 10 power 4. So if you will take n square, means that will give you TLE. So in this case, you have to optimize your code. How to optimize? If you remember, in the question it is saying it is sorted in non-decreasing order. And remember, any of the information in the problem, if it is given, it means it does have a value. And it will help you to optimize your code. So if the question says it is sorted, remember, 2 pointers we apply when the array is sorted. And in this case, we can blindly apply 2 pointer because array is sorted here. Okay. So this was our brute force code. Now let's see the optimized code with 2 pointer approach, and let's see the time complexity as well. So for the 2 pointer approach, what it says, 2 pointer says you will start your left pointer from 0 index, left side, and right pointer from the right end side. And now your task is to add it and see if it matches with the target or not. Okay. So what 2 pointer says, you will initialize your left with 0 and you will initialize your right with n minus 1th index. And your task is if nums of left index plus nums of right index is equal to target. So if these are same, your task is to return your left and right. Okay, new integer array. Okay, if this is equal to, then we will return the same index. But what if it is greater or if it is smaller? Okay, let's call this one as a sum. Okay, this is as a sum. Now, if our sum, currently your sum is greater than target and you are asking for lesser number. So what do you think? If 2 and 15 is total, it is 17 and you want lesser number. So in that case, you need a smaller number to be added instead of the larger number. And compared to 2 and 15, which one is larger? 15 is larger. So don't you think if you will go with 2, same, and this time 11. So now you can say your final answer has been decreased. Okay. In this case, 2 plus 11, it is still 13. Your target is 9, correct? Okay. So again, next time, what would you like to decrease or increase? Do you think you will increase I pointer and you will point it to 7 and your j at 11? That will decrease your answer? So whenever your summation is greater than target, you decreases the j pointer or right end. So what you will do, if it is greater, you will simply do right minus minus. Or else what you will do, if it is less than, then in that case what you will do, you will simply do left plus plus. And with this, you are done with the code. So let's try to calculate the time complexity here. Okay, so left and right both are moving. So there should be some condition to stop this. So for this, we will write the while loop here, while left is less than right. Why not equal to we have put? Because in the question it said we are not allowed to take the same element. Take the same element means if we will add the equal to condition here, then left and right, when they will be pointing to the same element, still the while loop will run. And suppose the element is 5 and target is 10. So we are actually looking for 2 different 5. But in this case, it will add the same 5 for 2 times and it will say yes, answer is present. But it might not be present. Hence, it is very important to stop this condition at left and not left equal to. So if you see more closely, what is the time complexity here? Every point left or right, they are only touching one number or one index. And if that index touched by left already, it will not be touched by right. Because this while loop will end there, means the total time complexity for what the while loop is running is only O of n. And inside it, it is just if or else check that requires only O of 1. So hence total time complexity is O of n in the case of 2 pointer approach. And this is how we decrease from O of n square time complexity to O of n with the help of 2 pointer approach. But remember, this is only allowed when the array is sorted. When the array is not sorted and time complexity or constraint is very small such that we can go with larger number, in that case we will sort the array first and then apply the two-pointer approach. Or else, if we are not allowed to sort it, we will use the hash map concept there. So that's it. Now let's jump on to our code editor and let's submit this code. So the thing is, first we will make a left pointer and then we will make a right pointer pointing to n minus 1. But what is this n minus 1? So let's calculate. N is nothing but nums dot length. Okay. Now we have to make our while loop ki while left is less than right. Our task is to calculate the summation and store. So it will be numbers of left pointer plus numbers of right pointer. And now the condition check. If this sum is equal to target, then in that case we will simply return new int and left pointer and right pointer. Else if sum is greater than target, what we did here, we just decrease the right pointer, else we will increase the left pointer here. Remember, we have to give left plus 1 and right plus 1 because it is asking, see here in the example number 1 you can see for 2 and 7 the index should be 0 and 1, but it gave 1 and 2. So hence we have to return like this. So we will now let's run this code here. Okay, sorry, it is numbers dot. Now here we have to return because suppose if the answer is not there, and now after this we have to add a return statement. So we will simply return -1 saying we don't have any such answer exist. Let's run this. Okay, now let's submit this and let's see the time complexity. See, it is 96.28%, means it is faster. So we are already done with this first question, which is to sum 2, which is already available on LeetCode. The problem link and the code link will be there in the description along with the Rising Brain sheet as well. Do check it out. And if you really like the video and understood each and every concept here, then do let me know in the comment section. Let's meet in another video with some more interesting question. Till then, keep learning, take care of yourself and your family.